Hello everyone, this is Dr. Isha Bose and I'm going to take you to the journey of quantum mechanics. And we will begin with the concept of an ideal black body. Before we go deeper into the topic, I would just like to talk about the electromagnetic radiation spectrum first because this is a very important topic and we will be requiring to mention this time and again while we are discussing about the black body. Alright. So what is the electromagnetic spectrum? Well, light is the most common example of electromagnetic radiation. It has two components, namely electric and magnetic fields, which are perpendicular to each other and perpendicular to the direction of the propagation of the wave or radiation as well. Now, light is only a very small part of the entire electromagnetic spectrum. We have infrared, then microwaves, radio waves, all these things in the lower wavelength region beyond the visible range. And when we go in the higher end, we see ultraviolet, X-rays, gamma rays, and so on. So this entire spectrum, this entire wavelength range actually required or present in the electromagnetic spectrum. And in the subsequent slides, whenever we are going to talk about radiation, it is only the electromagnetic radiation that we are going to talk about. Okay. Now coming back to the topic. What is a black body? Well, the name itself is a clue. Black. When do we see things black? When it does not reflect or emit anything out of it, isn't it? When we cannot see anything, we say it is black. Let me give you another example. Have you ever seen a piece of iron at room temperature? How does it appear? Blackish, metallic, isn't it? A little bit shiny maybe. But why is it looking like that? It is because it reflects that particular wavelength or maybe a combination of wavelengths and appears of that color to our eyes. If we take the same piece of iron and heat it for some time, what do we see after a little while? We see that it becomes red hot. Well, why is it red at that time? Because at that time, after absorbing the heat, it starts emitting the radiation, which is of the wavelength corresponding to red. Now, if I keep another piece of iron beside it, touching it, and I touch the second piece of iron after some time, what do I feel? Obviously, it would be hot too. Which means the first piece of iron has transmitted a part of its heat to the later body. Again, think of the entire process that we have been talking about. This piece of iron at room temperature, heating it, keeping it in touch with another thing. By mentioning all these, we have brought in the concepts of absorption of radiation, absorption because it has absorbed the radiation in terms of heat when we were heating it. Then, while we were looking at it at room temperature, it was reflecting. When we heated it, it transmitted a part of its energy to something which was touching it, and later on it started emitting radiation in terms of the red wavelength that we could see. So anything that absorbs radiation, transmits and reflects a part of it, and starts emitting radiation when further heated can be called as a black body. Okay. Now you must be confused that when we are able to see it, why are we still calling it black or black body? Well, now I would like to give you the definition of an ideal black body, and then there will be no more doubts. Defining an ideal black body is done like this. It is a body which absorbs radiation of all wavelengths of the electromagnetic radiation spectrum, does not transmit or reflect any part of it, and emits radiation of all wavelengths when further heated. So, if the body doesn't reflect or transmit, can we see it? No, isn't it? So, it is invisible to us and black. So, the first part of the definition gives us the answer why we call it a black body. Because while it is absorbing the radiation, it is neither reflecting or transmitting any part of it. So, an ideal black body absorbs every radiation falling on it and then emits radiation of all wavelengths without reflecting or transmitting. Now, if you ask examples, in reality, there is no such thing as an ideal black body. However, Sun is a very close example of an ideal black body. It absorbs almost the entire spectrum of the radiation, electromagnetic radiation spectrum, and can emit a lot of it. However, anything and everything around us are black bodies, but are the very bad ones. We absorb very little part of the entire spectrum range, and we emit also in a very small region. So, I hope you've understood what is the definition, or rather the concept of an ideal black body. It's just like the concept of an ideal student. A student who absorbs all the knowledge given to him via lectures, videos, from the teachers and from other sources, who absorbs all these knowledge, does not gossip or forget while the classes are going on, and then during the examination writes all the answers properly. So he absorbs everything and then later on emits everything. I hope with this example you will be able to remember this entire concept properly. So an ideal black body is the one which absorbs radiation of all wavelengths and emits radiation of all wavelengths later on when it is heated, provided it has not lost any part of the energy by transmitting or reflecting it. That's all for now. We will have a lot more coming up in the next videos. See you soon.